Volkswagen and Audi have been fitting turbochargers to a variety of vehicles since about 1981. With the aid of a turbocharger, it's possible to use the energy contained in the exhaust gases to compress the intake air required for combustion. This improves the filling of the cylinders and allows more fuel to be injected, consequently increasing both the torque and power output without increasing the size of the engine. The diesel engine is particularly well suited to turbocharging. This is because there isn't a throttle valve to restrict the flow of air through the engine. Therefore, the turbo can be kept spinning even when the engine is under part load. The turbocharger, which is fitted in the exhaust manifold, consists of a turbine and impeller mounted on a common shaft. The exhaust gases drive the turbine, and the impeller compresses the intake or combustion air. So the faster the turbine turns, the more the combustion air is compressed or boosted. In turn, the more the combustion air is boosted, the greater the volume and flow of the exhaust gases, and so on, as the cycle is repeated. Obviously, the engine can only withstand a certain amount of boost pressure, so a limiting valve, known as the wastegate, is fitted. The wastegate opens at a predetermined boost pressure and allows exhaust gases to bypass the turbine unused. The turbine subsequently slows down and the boost pressure is reduced. The reduced pressure causes the wastegate to close and the cycle is once again repeated. So as you can see, the wastegate is an essential component as it accurately controls the boost pressure. The exact boost pressure figure varies depending on the engine, but it is usually around 0.7 bar above atmospheric pressure. In the event of the wastegate ever failing to open, a safety valve, or dump valve as it's known, is included. Installed directly into the inlet manifold, it opens at a pressure slightly above that of the wastegate. Therefore, if the wastegate should fail to open, the excessive boost pressure opens the dump valve and escapes into the intake system, thereby avoiding possible engine damage. To increase the engine's output, extra fuel must be supplied in addition to the greater volume of air provided by the turbocharger. Turbo models are fitted with a boost pressure enrichment device. This consists internally of a diaphragm which is connected via a linkage to the pumping element of the high-pressure injector pump. Externally, a hose connects it to the inlet manifold. When the engine is idling or under part load, no enrichment is necessary, so the injector pump operates as normal. However, above part load, the combustion air is boosted to above atmospheric pressure by the turbocharger. The boost pressure pushes the diaphragm down, which in turn increases the working stroke of the pump. Consequently, more fuel is injected and the power output of the engine is increased. As the engine returns to a part load situation, the turbocharger slows down, the boost pressure reduces, and the fuel enrichment device returns to its normal position. As you can appreciate, under full load conditions, a vast amount of heat from the exhaust gases is directed to the turbine end of the turbocharger. The shaft which carries both the turbine and the impeller is subjected to extremes of temperature. While the vehicle is moving, some of the heat is dissipated by the normal airflow over the unit and the cooling effect of the circulating engine oil. However, when the engine is switched off, both these cooling effects are lost. Under these conditions, it's possible for the engine oil to carbonize on the turbine shaft, eventually leading to wear of the turbocharger bearings. So it's good practice, after a fast journey with any turbocharged engine, to allow it to idle for about a minute before switching it off. This allows the circulating oil to take away some of the excess heat. To cope with the extra heat generated by turbocharging, the engine's lubrication system has several additional features. These include oil jets to cool the underside of the piston crowns, a larger capacity sump and oil pump, and an oil cooler or heat exchanger. The cooling system often has extra components. For example, an electric pump to circulate the coolant after the engine has been switched off. The pump is usually triggered by a temperature-dependent switch and is sometimes accompanied by the after-running of the radiator fan. Some later models, for example the 1991 Passat, use a water-cooled turbocharger to improve the cooling. Charge air cooling, or intercooling as it's sometimes known, offers a further improvement in power output for the turbo diesel engine. Under full load conditions, the compressed air leaving the turbocharger can reach temperatures of 110 degrees centigrade before it enters the engine. The charge air cooler, which is installed in the inlet duct between the turbocharger and the inlet manifold, cools the compressed air by about 50 degrees centigrade. As the air is cooled, it becomes more dense and consequently contains more oxygen. This further improves the filling of the cylinders and hence increases the power output. The Umwelt diesel, as mentioned in part 1 of the program, provides a further reduction in emissions. This has been achieved in several ways. Firstly, the swirl chambers have been narrowed. This has the effect of smoothing the combustion process and lowering the combustion temperature within the swirl chambers. In turn, this lowers the NOx emissions and helps to reduce idle vibrations. The injector nozzle area has also been redesigned to modify its spray characteristics and improve noise emissions. Design changes to the injector pump have resulted in a load-dependent point of injection mechanism being included. For example, this retards the point of injection when the vehicle is decelerating, so helping to further reduce NOx emissions. Also to improve emissions, a reduction in injector dribble has been achieved by the inclusion of new delivery valves within the pump. An important feature of this engine is the turbocharger. Unlike the turbocharged engines we described earlier, this turbo is not specifically fitted to increase the power output. As no fuel enrichment device is fitted to this engine, the compressed excess air provided by the turbo is used to burn the same quantity of fuel more thoroughly. In comparison with previous engines, this substantially reduces the production of particulates, commonly known as soot, at full load and high altitude conditions. An added bonus is that the power output and the torque are actually increased by about 11%. in comparison with the naturally aspirated diesel of the same size. The specific fuel consumption is also improved. To reduce emissions even further, the vehicle is equipped with a catalytic converter. However, unlike those fitted to the petrol engines, this is a two-way or oxidation cat, as it's often known. Inside, its construction is similar to the petrol engine's cat, other than the composition of the noble metal coating. Platinum is used to promote the catalytic action, which results in a reduction in carbon monoxide and a lowering of hydrocarbons. A further benefit is that the unpleasant smell normally associated with diesel exhausts is also reduced. In conclusion, when compared with the naturally aspirated engine, the Umwelt diesel achieves excellent results in the reduction of HC, CO, NOx and particulates. It more than meets the requirements of the USA 49 state standards. Before starting, here's a point to note. As diesel fuel can cause skin problems, always wear protective gloves or a barrier cream before coming into contact with diesel fuel. Many of the engine checks and adjustments are similar to those already described in the previous diesel program. So in this section, we will only look at the items that are specific to these engines. The turbocharger requires no routine maintenance. Only when you suspect that the turbo or wastegate may be at fault due to a lack of performance is it necessary to carry out a check. Firstly, examine all the hoses and air ducts to ensure that they are neither blocked nor leaking. And of course, it's essential that the engine's basic condition and settings are all correct. Don't forget the obvious, such as a blocked air intake or filter element, restricted fuel line, or an incorrectly adjusted throttle cable. Using a T-piece, connect the boost pressure gauge, VAG 1397, to the hose between the inlet manifold and the enrichment unit. Note that on most of the Umwelt engines, the gauge can be connected directly to the manifold. Position the gauge inside the vehicle with the valve uppermost, and make sure the hose is carefully placed to avoid it being trapped. Open the valve and road test the vehicle. You will require a second person to read the gauge. Taking care to obey all traffic regulations, select second gear and open the throttle fully. Simultaneously, apply the brake to reduce the speed to about 35 miles per hour and note the boost pressure. To facilitate reading of the gauge, the value can be stored by closing the valve. Compare the pressure with that quoted in the repair manual. If the boost pressure is too low, seal off the hose to the dump valve and repeat the test. If the pressure is then correct, replace the dump valve. On the other hand, if the boost pressure remains low, clamp off the hose between the T-piece and the enrichment device and repeat the test. If the pressure now rises, then this would indicate a leak in the boost pressure enrichment device, and the injector pump will need to be replaced. If the pressure remains low or drops even further, then it's probably the turbocharger or wastegate that is at fault, and it will need to be replaced. However, always refer to the latest repair information, as tests and procedures can change. A further point to note regarding the fuel system of the turbo engines is that the fuel injectors are set to a higher braking pressure. The 5- and 6-cylinder engines have two toothed belts. As you can see on this 2.4-litre transporter engine, the one at the front drives the camshaft and water pump, and the shorter belt at the rear drives the injection pump. As the two belts are connected via the camshaft, any adjustment made to the front belt will affect the setting of the injection timing. So any repairs or adjustments affecting the front belt must be followed by checking the valve and injection timing. So, here is how to remove, replace and adjust both belts. Don't forget, if you intend to reuse the belts, mark their direction of rotation before removal. Set the engine to TDC on number 1 cylinder. If the engine is out of the vehicle, you will need to use the special tool to determine the TDC reference point. Lock the injector pump gear with the 2064 pin and remove the drive gear from the rear of the camshaft, complete with the toothed belt. On some earlier 5-cylinder engines, you will first need to remove the brake exhauster pulley. To remove the front belt, first slacken the vibration damper bolt. Check that the engine is still set on TDC and lock the camshaft with the locking bar. Make sure the bar is centralized by inserting feeler blades as described in the previous program. Slacken the belt tension by loosening the water pump bolts and moving it round on its mounting. Remove the belt, complete with the vibration damper and crankshaft gear. Recheck that the engine is set to TDC and that the setting bar is correctly located in the rear of the camshaft. Slacken the camshaft gear by releasing the bolt and striking the gear with a hammer and punch. Fit the toothed belt complete with vibration damper and adjust the tension until the correct value is recorded on the VW 210 scale. Recheck that the crankshaft is still set to TDC, correcting it if necessary, and tighten the camshaft bolt. Finally, remove the setting bar and tighten the vibration damper and any remaining bolts. Firstly, on those vehicles equipped with a cold start lever, make sure it is in the off position. Older 5-cylinder vehicles are fitted with a WACStat, which automatically regulates the cold start device, dependent on the coolant temperature. So on these models, the linkage must be temporarily decoupled to release the lever. Check that the crankshaft is set to TDC on number 1 cylinder and the injector pump gear is aligned with its reference mark. Lock the gear by inserting the pin. Fit the rear camshaft gear and toothed belt and slightly tighten the securing bolt. Leave the bolt sufficiently loose to allow the gear to be turned without moving the camshaft. Check the belt tension using the VW 210 and adjust it if necessary by moving the pump's mounting bracket. Remove the locking pin from the gear and the plug from the rear of the pump. Fit the 2066 adapter, extension pin and dial gauge. Adjust the dial gauge to about 2.5 millimeters preload and check that the crankshaft is still aligned to TDC. Use the 3036 bar to turn the injector pump drive gear in the opposite direction to normal engine rotation until the dial gauge needle stops moving. At this point, zero the gauge. Now turn the drive gear in the normal direction until the dial gauge corresponds with the setting value shown in the repair literature. Hold the drive gear in this position and tighten the securing bolt. The setting must now be rechecked by first turning the engine crankshaft in the opposite direction to the normal rotation until the dial gauge reads 0. Then turn the crankshaft in the normal direction until the TDC marks are once again aligned. Note the dial gauge reading and write it down. The value may be slightly different to that previously set due to a certain amount of movement in the belt. The deviation between the two values can be calculated by subtracting one from the other. The point of injection should now be readjusted to the setting value plus the deviation figure. Once this final correction is complete, check that the drive gear bolt is fully tightened and refit the remaining components. And a final point to remember. If the vehicle is fitted with the Wackstat-operated cold start device, return it to its normal position. Don't forget, providing a dynamic timing figure is given in the idling and emission data book. You can check the timing with the electronic equipment described in the previous program. The idle and maximum speed adjustments, which should always be checked after adjusting the point of injection, are described in the repair manual. Some Audi 100 5-cylinder turbo engines are fitted with a slightly different type of injector pump. An electrically heated expansion element takes care of the idle speed boost when the engine is cold. And this unit advances the point of injection during cold starting. Apart from these two items, adjustments to the pump are made in a similar way to the previous models. The repair procedures for the 2.4-litre Taro engine are similar to the other diesel engines included in this series. So here, once again, we will only highlight the main items that are specific to this engine. Unlike the other engines, the compression gauge is fitted in place of the glow plugs. You will require both the gauge, VAG 1381, and the special adapter, VAG 1381/11, in order to connect it to the engine. Once the gauge is fitted, check the compressions in the normal way and compare the pressures with those specified in the repair manual. The glow plug system comprises an electronic control unit mounted on the passenger side A pillar area, 2 relays, a resistor fitted in the inlet manifold, a coolant temperature sender, and a fusible link. The system is of the extended glow type. In other words, the glow plugs remain lit at a reduced voltage for a period of time after the engine is started. A complete description of how to test the system is given in the repair manual, but here's a point to note. An initial check of each glow plug can be made by checking it for continuity with an ohmmeter. Open circuit indicates a defective plug, while continuity shows it's probably in order. To improve visibility, we're working on an engine out of the vehicle. The toothed belt which drives the camshaft and injector pump requires replacement at regular intervals. To remind the driver, a warning light illuminates on the dashboard when the specified mileage is reached. Set the engine to TDC on number 1 cylinder. In this condition, the marks on the crankshaft, camshaft and pump will align with their reference marks. If the belt is going to be reused, don't forget to mark its direction of rotation. To simplify refitting the belt, install a bolt into the pump gear until it just contacts the casing. This holds the gear in position while the belt is removed. Slacken the tensioner pulley and move it to the left. Slightly tighten the bolt to hold the pulley and remove the belt. Check that the gears of the crankshaft, camshaft and injector pump are aligned with their respective reference marks. Carefully fit the belt, ensuring that none of the gears move from their reference marks. By the way, unlike the previous engines we've looked at, the camshaft gear is located by a keyway. Slacken the tensioner pulley bolt to allow the automatic adjuster to tension the belt. Remove the locking bolt from the injector pump gear and turn the crankshaft in the normal direction 4 revolutions to settle the belt. Recheck that the reference marks are still aligned and fully tighten the tensioner bolt. After replacing the belt, don't forget to cancel the warning light by pressing this button. However, if you have replaced the belt before the recommended mileage, then the warning light counter mechanism will have to be adjusted. Consult the repair manual for further instructions. The injection timing or point of injection is adjusted in a similar way to the other engines. With the engine set at TDC on number 1 cylinder, remove the plug from the rear of the pump and install the dial gauge and holder. Preload the gauge. Release the automatic cold start device by inserting a spacer of 10 mm between the lever and the waxstat. Turn the crankshaft anti- or counterclockwise until the dial gauge needle stops moving and reset the dial to 0. Now turn the crankshaft clockwise until the TDC and reference marks are once again aligned. The dial gauge reading should correspond with the plunger stroke figure shown in the manual. If the reading is incorrect, slacken the pump bolts and rotate the pump until the correct figure is recorded. By the way, always fit a new copper washer when refitting the injector pump plug. And don't forget to remove the spacer from the cold start device. As with the other engines covered so far in this program, various thicknesses of head gaskets are available. The thickness is identified by the position of a notch in these areas of the gasket. Additionally, the gasket's corresponding identification letter is stamped here. In production, 5 different thicknesses of gasket are used, ranging from size A through to F. For service use, only 3 are available. To identify the correct thickness of gasket required, first turn the crankshaft to TDC. Mount the magnetic plate and dial gauge so that the pin rests on top of the piston with a 3 mm preload. Check the exact TDC position by rocking the crankshaft back and forth slightly until the highest reading is recorded. At this point, zero the dial. Determine the piston protrusion by carefully sliding the gauge off the piston. Repeat the measurement on the other side of the piston and carry out the same procedure for all 4 pistons. Use the largest value from the 8 measurements to select the correct gasket from the table in the repair manual. Incidentally, the cylinder head bolts are tightened in a similar way to the other diesel engines. But unlike the previous engines, the head bolts can be reused, providing the diameter of the thread is greater than the minimum quoted in the repair manual. The valve clearances are adjusted by shims. With the engine cold, set the crankshaft to TDC on number 1 cylinder. In this position, the inlet valve clearances of cylinders 1 and 2 and the exhaust valve clearances of cylinders 1 and 3 can be checked. Turn the crankshaft 1 complete further turn to check the inlet valve clearances of cylinders 3 and 4 and the exhaust valves of 2 and 4. Note the clearances of any valves that are not within the tolerance quoted in the manual. To remove a shim, turn the crankshaft until the cam lobe is upright. Depress the bucket with the special tool and remove the shim. Although the size is not etched onto the shim, a number is. The number corresponds to a particular shim size and can be identified by looking at a simple chart in the manual. Don't forget, fitting a thinner shim will increase the clearance, while a thicker one will decrease it. You can use the formula in the maintenance book or engine manual to calculate the exact size shim required. When refitting the shim, remember to fit it with the etched number facing down. Before replacing the rocker cover, apply the recommended sealing paste to these 4 points. The fuel filter assembly is fitted with a drain tap and a warning light switch. Once a certain level of water accumulates in the bottom of the filter, a dash warning light is lit. To change the filter, first drain it and then unscrew the cartridge. Fit the warning light switch to the new cartridge and refit the filter. Finally, use the hand pump to prime the system. Before checking and adjusting the idle speed and maximum RPM settings, make sure that all the prerequisites described in the repair manual have been met. Check that the throttle lever is against the stop and then set the idle speed by turning the screw. Before checking the maximum speed setting, stop the engine and hold the accelerator to the floor to ensure that the throttle lever contacts the maximum speed stop screw. If necessary, adjust the linkage. Start the engine and briefly depress the throttle to note the maximum revs. If they are incorrect, adjust the stop screw accordingly. So, this completes the second program in this series about the indirect injection diesel engines fitted to the Volkswagen Audi range of vehicles. Of course, it's impossible in the time available to cover every adjustment and procedure you may require when working on the engines. However, with the explanations provided in these two tapes, together with the workshop literature and practical experience on the vehicles, we hope you now feel more confident when faced with the repair to a diesel model.